Hi, data fan! I stumbled on this JavaScript charting library called Chart.js, and I kind of like the aesthetic. The colors are flashy. Let me show you one of the code examples. If I go to bar chart border radius, as you can see, the color are flashy, and the tooltips are nice. I like the round edges, and when I select one of those legends, yeah, the animations are pretty smooth, and I do want to see more of those. Let's go to stack bar chart. Yeah, that looks nice. And if I scroll under to see how do we define one of those charts, you'll see that it uses JSON specification. So here we define a config of type bar that uses the data, which I guess is inside this setup tab. And here you've got your data sets with probably random numbers and background colors. And this is the data that is going to be used inside this JSON. And you got your options with the plugin's title. So I guess there's a title here. Here's your title. There's a randomize button. I guess this comes from here. So you've got actions that are injected somewhere. I don't know where. But anyway, what we need to understand is to render this chart, we are using this JSON specification. And there's probably a Chart.js component renderer that transforms this JSON into this beautiful chart. And I kind of want to have a similar thing inside Streamlit, in the same way as how I use eCharts. Each of those charts is actually a JSON that was transformed into a Python dictionary that is injected inside the eCharts component. So this is all JSON, all JSON, all JSON. And if you go inside the examples for this line chart, you can see in the source code, you've got the JSON, which here is a Python dictionary that gets converted into JSON, which then gets converted into this beautiful chart. I'm too lazy to build a Streamlit component for Chart.js, so I will let a coding agent do it for me in 2 prompts. So I can show you all of my workflow for kind of vibe coding, prototyping, and you can do it for yourself if you follow along. I am going into this video with zero preparation. I have way too many things to do, so hopefully coding agent will do in 1 try. Okay, but first I need the template, because there is a template from the Streamlit team to build components. And I think we can find it if we go on GitHub Streamlit. If you go on the Streamlit organization, you will find all of the repositories from the Streamlit team, and especially this component template. And in component template, you will see a Streamlit component is made out of, there's a lot of talk. I am not going to read all of this. But in the quick start, ensure you have UV, Node.js, npm, UV, which is your Python environment and package manager. That is very easy to use and set up. I definitely recommend it. And you've got your Node.js, which is kind of like your Python, but on the JavaScript server side. So when you want to run JavaScript on the server, you use Node.js. And npm is like your UV, or maybe more like your pip. You use npm to install JavaScript packages into your project. You'll be able to do npm add, or npm install, npm run dev, just like you use pip and UV. And then you use the uvx command to run a cookie cutter template to copy and paste this template into a new project. So let's copy this and open a new command line. I have a dedicated folder for my Streamlit components, and let's paste our uvx from cookie cutter, and your Streamlit component template. Yes, download it again. My name is, let's say fan. Let's go for an email. In the PyProject toml file, there is an author line, and this will be the author name, and the author email will appear there. If you push your package into PyPy, well, PyPy is going to display your name as the maintainer of the package. Then, this is a Streamlit Chart.js and package name, import name. I think for now, I recommend you don't touch the default values that are given here, because there's a link in the way Streamlit Components v2 template works. There's a link between the two of those, and I don't exactly know how it works and how it doesn't work, so just don't touch it for now and just give it a good name so that the package name and import name is good looking. Streamlit components for rendering Chart.js, MIT, and then we are going to select pure TypeScript, because my Streamlit eChart component is in pure TypeScript, and this Streamlit eChart is using Streamlit bokeh as a model, as for inspiration. So I kind of want Streamlit Chart.js to have the same architecture as those projects that I kind of already know about. So pure TypeScript it is for now. Is it already copied? There you go. You've got your, let's here, Chart.js is here. And then you've got your Streamlit bokeh, your Streamlit eCharts, even component template is here. Yeah, I copied a lot of Streamlit components to read them when I'm bored. That's how I go to sleep at night. No, that's not true. Okay, let me zoom a little, and let me hide. Okay, maybe let me put my face on the right, and then we are going to let's go inside this folder first, and there I will open Visual Code and Claude Code. I don't need you yet, and here's your project example readme Streamlit Chart.js. Let me zoom a little. Okay, that looks nice. I don't know why you are showing. I don't want you. So here's your Streamlit Chart.js, Streamlit component for rendering Chart.js. How you install it, but we are in development mode, so we are going to run uv pip install, force reinstall. Let me let me bring this side by side for now. And here I've got my Streamlit Chart.js. I am going to run uv pip install, and there's no environment yet. If you open the project, you will see that there's no virtual environment at the location of this project. So I need to build one. So uv-venv, it tells you now there's a virtual environment, and you can run your Python commands from this virtual environment by using uv-run and a script. We don't have anything yet, so let's uv pip install the local folder, force reinstall in editable mode, so that every edit I make in this project is indeed installed in the virtual environment. Pip install, wait for packages, and flip vertical, not flip vertical, horizontal, and vertical. Yeah, that's better. Oh, this works. Oh yeah, woo. Yeah, sorry, and now it's a little better. So if I do uv run streamlit run example.py, it should run something. Streamlit is inside your uv, and now you can see that Streamlit's component must be declared blah blah blah. So this is an error, but I think this is because there's no JavaScript code yet that the Streamlit component can load. So we need to look into it. Let me go back to my VS Code. Here's our current project. We have our example.py, which loads Streamlit and a Streamlit component, which is located here inside Streamlit underscore Chart.js. Now in there you've got another Py project that defines this asset dir. If you remember, this was actually the asset dir. Here you see asset dir and asset dir, which points to front-end build. And front-end build still does not exist. There is nothing in this folder yet. So here we've got our component which is looking for JavaScript code. And we now need JavaScript code. Let's go to our command line and we are closing this, clearing a little and heading to Streamlit Chart.js and the frontend. Now, frontend is your frontend code. You've got a source, package, tsconfig, and vit. This package.json, if you show it, it has the name of the Streamlit component and blah, blah, blah. But more importantly, there are dependencies here. There's the JavaScript dependencies for Streamlit component v2 and a few other dependencies like TypeScript or vit. So to install those dependencies locally, we have this npm command, which is called npm I or npm install. And by the way, don't worry, they're all located inside the README here. So here you've got your npm I for installing the dependencies that are located inside this package.json. So now it is going to run. Now you should see this node modules. This node modules is kind of like your virtual environment here, and your node modules is like all of your JavaScript packages that were downloaded from the web into your local folder. And now if you run npm run build, you are going to build. What is going to happen? You are going to build this front-end build. And this build folder contains a JavaScript file. And this is the JavaScript file that our component is looking for. So normally, fingers crossed, if we run UV run Streamlit again, let's go Streamlit run example. We are not at the correct place. cd, let's go back here and run our Streamlit again. And now we did it. We have our hello world. I think I can show you the code actually. I remember. So let's show where is the code? There's the code, and here you go. You've got your example.py, which has a subheader. This is the subheader components with constant args, and then you've got your Streamlit Chart.js here with world. I guess this world is this world here. So if I say hello fan and save and always rerun, there I see the hello fan. And with up, yeah, that's better. And then next we have this result, which is apparently state that comes from Streamlit Chart.js. So whenever I interact with the app, the Streamlit script is going to rerun from top to bottom. And by rerunning from top to bottom, the result here will contain the new value, the updated value from the state of the front end here. So if I click here, it reruns from top to bottom. Result becomes 1 and it's displayed here. You've clicked one time, which is this part. So I will click a lot. There you go. And every time I click, it reruns very fast because Streamlit is ultra fast now. And this result equals 17. and then you can edit the name of the component, and yeah, that's nice already. And we can head to the component. If let me show you the code. The component is, what are you loading? Don't load. Example is going to load the component from Streamlit Chart.js, which is here and here. You've got here your component, which sets up an HTML tag with a h1 header and a button with a click me, and some JavaScript code. And this JavaScript code comes from the front-end build that is defined inside this Py project. So now you'll be like, where does this build file come from? Well, if you want to understand it, you go to this vit.config.ts file, which defines how your JavaScript code is built all together. So here in this vit.config file, you will see this lib, which takes as entry the .src index.typescript with the name my component, and there's a lot of other files and config. So if I go to the src, there you will find the source code of your Streamlit component. So here you can see your front-end states, which comes from the Streamlit v2 library, component data, which is the TypeScript class for the interactions between the Python and the JavaScript. So they're going to exchange component data instances. Here there's a weak map. I think it manages multiple components of the same component class. So all of the instances are going to be stored inside a weak map or something. I don't remember, but it's commented here. Yeah, I am not really good at TypeScript. I admit I'm not very good at TypeScript. And yeah, there's a lot of code, front-end renderer, which I suppose comes from component v2. And here's your component. And yeah, let's try to find what happens when you click on the button. So here it sets up the content of the button. Yeah, of the button. Is it the button? Wait, is it the button? Yeah, here it is. It is this hello fan. And it comes from this h1. This h1, if you remember, it was being defined inside the Python part here. You've got the h1 and the button, and those are targeted by our index, so that this h1 is injected with the name of data, which name comes from example.py. Here, fan is injected by component data. So component data extracts the name from the Python side and injects the name inside the h1. And then we search for the button and we attach a handle click on the button so that every time someone clicks on it, we set a new state value, which is also from the Streamlit component library. So this set state value, whenever you set a state value, this is the method that calls for a Streamlit rerun from top to bottom and injecting the updated state value in the Python variable. So when you say set state value of numclicks and numclicks, it is going to send back this numclicks value back on the Python side. And numclicks here is internal component state. So you use set state value. This is sent back to the Streamlit side, and on the Streamlit side you will see here in the component, I think it is here, where it is, out name key default numclicks and component value, but I think this component value contains the numclicks states. And if I go back to the initial code, here it is, the result numclicks, which is the numclicks from the set state value, which is being passed back to Python. Phew, that was That was a lot of information, right? But just see that if you're using the TypeScript, JavaScript templates, everything is set up for you. You've got the front-end state, the component data, front-end renderer, num clicks number, the per component inside the weak map. Everything is set up for you. And understand that this is where, if you want to do it by yourself, you download the Chart.js package and inject it inside this index.ts to look for the JSON data that is going to be here. Here is where we're going to put the Python specification of the chart, and we load this inside the Chart.js in the my component. You start to realize that's how you're supposed to do it, okay? Okay, this sounds simple, right? And by the way, you may ask me, but Fanil, how do we update this build? Does that mean that every time, let me close this. Does that mean that every time I want to rebuild the front end, I need to open a new terminal, go to my front end and rerun npm run build? Well, if you want to know more about this npm run build actually runs the script that is defined in package.json. So here the package.json contains a build, which is the same as this npm run build. So here you see it npm runs clean, then type check, then builds the front-end production, which is here, which means there's a dev here. So npm run dev instead uses Vite to build and watch, so live reload, this build folder. Every time there's a change in the source code from index.ts, it will rebuild the JavaScript file inside the build, and you'll be able to see the result immediately inside your example.py. So you can very easily edit your Streamlit component while watching at the live result. Let's actually try it instead of just speaking, you know. So we've got our Streamlit is still running here. Let's run npm run dev, and now it is watching for file changes. Let's go in our index.ts, and maybe also, did I forget to put my, where is it, by the way? Is it this one? Yeah, it is killed. So localhost 8501. Here's our Streamlit. And there you go. You will see hello. And then if I put a lot of exclamation marks here and save, it should reload the component. Did it rebuild? It should have rebuilt. And if I rerun, yeah, I need to rerun. I think I didn't define yet auto rerun. You need to define it. You prefer dark or light. If you auto rerun, now you can edit your component, save, it's going to rebuild the build folder, and then if you rerun your example.py, it reloads the component with the new build folder, and it displays it for you. So you can visualize in real time the output of your component, which means if you link a coding agent to editing the code here and the Python code, you can visualize in real time what is happening inside the web browser. So that's a good small win. We did a lot right now. Okay. Actually, I am too lazy to go and edit the code right now because I didn't prepare anything. So instead, let's have our command line do it for us. Okay, by the way, instead, no, maybe not. Let's keep it this way for now. So we got this Chart.js. So here I have Claude installed, and I also have, let's see, if I open it on the side here very quickly, I have Gemini installed, and I also have codecs, but I'm using codecs from the IMP client. So let's go to CG chart. No, my Streamlit components. Where is my Streamlit components? There you go. And then Streamlit Chart.js. And here I can open Gemini from Gemini CLI, and in the same way, Streamlit I can open AMP for codecs. Okay, here's your AMP and your Gemini. I like to have them on the side generally, so I will keep them there. Gemini is telling me they're doing stuff, but whatever. So here is our Claude, our little agent. You're the little agent. Here's the little agent, okay? He's going to do all of the stuff for me. Huh? You do the coding while I do the sleeping. Isn't it cute? So the first thing is what type of tools and actions you can take. Because tools, like this flute here, are very important to actually do your work. You need to be able to choose the correct tool. Like this tool is not going to be a great tool for making rice or cooking rice. So you should use another tool for this, okay? Now the tools it has at his disposal, for me, first of all, are the tools inside the command line. So we are going to remove this and exit Claude for now and go back to our command line. In our command line, you have all of your classic ls, you've got your cd, your make dir, you've got your git that works as a command line tool. I installed a bit more like ripgrep, which is like a very high performance grep. You can see here immediately the file that contains Streamlit Chart.js. That's an example. I have UV, obviously, to run Python scripts. I have another one I like is GH, which is a GitHub client. So I can, for example, do I actually don't know how to use it. So we are going to build help. Yes, just issue a list of, does it work with Streamlit? Streamlits? It's not Streamlit. It is, all of this. Anyway, you can, from command line, list all of the issues from any GitHub repository. If I knew how to use it. But generally, the coding agent knows how to use it, which is very nice. I could, like for example, let's go to Claude just to show you. Let's use Haiku for this. Use the GH command line to get the top 10 most liked issues from Streamlit/Streamlits. And here, let me backcode this. And here, Claude Haiku, like this guy, there you go. It immediately generates the command line to do it. So the repo, I needed the flag repo, limit 10, sort by reactions, by desk. How do you say this in English? Ascending and descending values. So yes, I want to proceed. And there you go. It uses the GH tool to load the best issues from Streamlit. So this is one of my favorite ways of working with a coding agent, because I like to set up my own command line tools in Python or even Rust. I'm learning Rust right now to try and do my own. It's blocked right now. And oh, there's an error. So this is an error, but obviously coding agent reinforcement, it reads the error and will edit the command line to fix the problem. Fingers crossed. It will eventually get it. I should have put a stronger model maybe. I have put, if you're interested in the command line setup that I'm using, right now on Windows, I am using Windows Terminal Preview with PowerShell and Starship and a bit of NeoVim and a few more command line tools. You can go and read this GitHub tutorial. I did it 2 weeks ago, and I'm really liking this setup right now. Is it done? It is not done. Okay, please stop asking me for. Just do it. You can make it. I don't know what it's doing right now. I should have read. Okay, is it are you doing a demo effect right now? Okay, I am changing. I am changing model. Let's go back to Opus, and then yeah, the more you use those LLMs, and the more you understand what kind of tasks you can use Opus on, or Sonnet on, or Haiku on. Yeah, so Opus is having the same trouble. I mean, it will make it. As you can see, it is way fast. There you go. Support custom HTTP, etc. But there you go. When you need to augment or to enhance your coding agent, command line tools, best thing ever. And you can see, yeah, most of my command line tools, I use Scoop to download command line into my Windows machine. And there, I've got Caddy, DuckDB, FFmpeg, Git, LazyGit, Stripe. Yeah, I got a few of those. But I also want to limit the way you use your tools. So for this, there are multiple ways you can put in the context of the agent, like the Claude.md. You can say, don't use this tool this way, but you'll never know. Sometimes it will forget about its context. You know, it's a little, if he's a little drunk, it is not going to remember that it should not use this flute to actually hit on a nail. So if you want to prevent those non-deterministic, how do you say that, tool usage, you can use what Claude or Gemini or every classical coding agent called hooks. Because with hooks, you are able to use a script at certain points of the life cycle of the coding agent. For example, just before you or just after he selects a tool, you run a script to see if you're using the correct tool, or if I need to fix the tool that you're using, or I need to block the tool that you are using. Maybe with an example, it will be a bit easier, but what I like with Streamlit is they actually have practices that I really appreciate in their repo. If you head into their .cloud or every other whatever, you will find the settings.json, and here we go. You see here you've got hooks definition. Let's grab one of those. Every time you use a tool, just before you use this tool, you should run this script. Like for example, if it's a script that runs a bash command, you use this pre-bash redirect Python file before running the bash command. Or after you use a tool that edits or writes in a file, you run the post-edit autofix. And maybe I can actually show you. I think I've got Streamlit here. So I can go inside Cloud Hooks, and I think, let's go find the post-edit, the autofix, and there you go. This is the file, the script that is going to run just after the coding agent like Claude Code or Gemini Cli or Codex has edited any file. So here, every time you write or edit a file, it is going to do some auto formatting and fixing linked errors by checking first if the file path we're interacting with is a Python file. If it is not, we end the script. And if it is, we continue going on. Yeah, there's a whatever is going on. And then at the end, you use uvrun rough check and uvrun rough format, which means when your agent edits a Python file, it is going to immediately, after it edited the file, run a lint check and a auto format, which is really cool. because now you're pretty sure that your coding agent is following best practices because you're actually imposing them from deterministic scripts. And yeah, there are a few, wait, if I go back, there's actually, if I go to Cloud Hooks, you can find the whole, yeah, you can actually find, I think, there it is, all of the hooks that you can install, like, I think before using a tool, before asking for permission, after using a tool, when the task is completed, like, there's a lot of hooks that you can install. So don't hesitate to copy and paste. That's what I would actually do. I would go back to my VS Code, and then inside this .cloud here, so this I will remove. I would let's go and open a new window. I will find my, I think I've got my Streamlit components here, and paste. In this Streamlit folder, we have our skills and our settings.json. So we can copy the settings.json in our cloud, and then we also steal those hooks, and maybe a skill. Let's copy everything for now. And then we can talk about them later. So here you've got your hooks, and then in the hooks you've got the actual scripts that are going to be run. Very useful to control what your coding agent is doing. And okay, you may have noticed that there's even a permission list. So this permission list can define how autonomous your agent here is. For example, I don't use make, I don't care about make. Yarn should be, I guess, npm. And all of those will be allowed by default for the agent to use without having to ask for my permission. So yes, you can run UV run PyTest, you can run Streamlit, you don't have MyPy, you don't have this, you don't have this, PR list you can run, etc. All of those you can run. But every time you try to do a more like destructive command, like git push or git reset or git clean, well, you will have to ask for my permission. So if I close this and go back to my cloud, I don't need you anymore. Let's go back to my cloud. No, you are not cloud. You are going back to Chart.js. And now, if I try to have you git reset something, I don't remember. Is it git reset or... Oh, it's git reset hard something. Sorry. Run git reset hard of the folder. And first of all, there's a hook that runs. The run one hook, because this is a new bash command. So there was this script that tried to check the command beforehand, but I think I need to fix it because there's no make command. I don't have make on my side. Wait, let me check. There's a hook for pre-bash redirect that uses make to do something, I think. Is there a make? I think there is make somewhere. So I am going to remove those hooks. Actually, I think I am going to remove the hooks for now. But for a cleaner project, I would use them. Settings.json. And now permission rule bash git reset hard star requires confirmation. Okay, maybe it's time to actually think about how we are going to build this Streamlit Chart.js. Or maybe the better question is how this is going to build our Streamlit Chart.js component. And now he knows what tools it can use, from UV to GH to Git, etc. But you know, it also needs my brain. So because we would love to take what's in my brain and put it inside this coding agent's brain so that it's able to leverage the best practices that I've got stored here to actually build the component. So that is why I have all of my, let me show you again. If you remember, I stored all of the components here. We've got Streamlit bokeh, Streamlit eCharts, our project that we want to use to work on the Streamlit Chart.js library. So let's go back to our Chart.js and clear and open Claude again. And now we are going to add our Streamlit bokeh for this session. Oops, I missed. We actually added the whole parent folder which has Streamlit bokeh and Streamlit eCharts. Yeah, it's good to have it get cross knowledge from everything. Next, now that it's able to fetch the code from other reference projects for components, we also can tell it to use documentation from the web, because the training data inside our coding agent's brain is maybe not as updated as we would wish for. Like if I would go to, let's go back to model haiku for this, and maybe ask, how do I build a Streamlit component? Okay, this is not very specific, this is a little broad, so hopefully it will only leverage its own knowledge to answer the question. And if we zoom in, or maybe zoom out a little, you will see that in its brain, the LLM only knows about Streamlit Components v1. It doesn't know about the new, modern, better, faster, stronger, etc. Version of Streamlit Component. In that case, I would want to have my agent download the up-to-date documentation. So we can send, let's go back to, let's go to Sonnet for now, and search in the Streamlit documentation about, I don't know, let's Streamlit Components v2, let's say about building. The agent is going to search for Streamlit documentation. Maybe I can go to the right for this. So here, web search, I am going to use a tool to search for the web on the doc Streamlit domain and the streamlit.io domains. So now it's looking for it. A small issue about this is all of this information that it's fetching right now, yes and yes, this little coding agent is, let me show you my coding agent. This coding agent, it is going to work hard with its tool. Maybe this is the web search, and it is going to swallow all of the web search results inside its brain. And there you go. So as you can see, it is reading more and more documentation. So right now it's not a lot, it's only 300 tokens, but it is still 300 tokens stored inside his context. Okay, at this point I am too lazy to press yes, so I'm going to say yes. Please stop asking me if you need my permission for downloading data from documentation. I was saying it's an issue because now we've got 1,000 tokens, which is still not a lot, you know. I think it's a context window. Is it 1 million right now? But still, even if it's 1 million, it's 50% of 1 million to be considered good performance. So 1,000 is okay, but imagine if it's scrolling like the full documentation of Python. The more stuff you put in the context of the agent, the more it will maybe struggle on the later stages. This is small enough that they can keep everything inside its context, and you've got all of the information about components v2, and yeah, you can read about the differences, the key differences. But what I sometimes prefer to do is, instead of, let's rewind the conversation a little, instead of, there you go, so now I just forgot about the research I just did. Instead of having the coding agent uses a tool to put everything in his head. I like to use a sub-agent. So search with a sub-agent in the Streamlit documentation about building, about, let's say, the differences between Streamlit components v1 and v2. And now, instead of hopefully using a tool to put everything in its head, it is going to run a new explore sub-agent. Is it the new name? I don't remember, but I think it is. So this is a sub-agent. So what it means is let me look for a sub-agent. Okay, I got a sub-agent. So here, main agent, it spawns a sub-agent. It looks a little dumb. And then it sends this sub-agent to do the work for it. And then when the sub-agent is done, the sub-agent has got all of the information, but we don't want it to transfer everything back to the coding agent. He only wants a summary. So the sub-agent is going to provide only a summary of the key differences. He has all of the context that is maybe not as useful for the main coding agent. And when the sub-agent is done, oops, sorry, my bad. Coding agent has got the few information it needs to continue working. So when you're doing like larger searches, I like this method a bit better. Otherwise, they're going to grow context more and more. And when you break the 50% of the 1 million context window length, it is going to, it really gets worse. In terms of performance, it gets really bad. Okay, let's stop the search for now. We don't actually care about the results. And up. Another way. It's gonna come back here, coding agent. Sorry. I only wanted to build a Streamlit component, but I want to show you everything that's going behind the scenes of solving this, doing it into prompts. Okay, let's stop this one. Aside from this, there's one of the more popular ways of solving this is by using a library, not a library, but a website that is called Context7. So Context7, you can install a MCP server that connects to Context7, which has already parsed all of the documentations for LLMs to use. So I actually have I didn't set Context7 in Claude, but I did do it in Gemini. Because the way I sometimes work is I have Gemini do all of the research work and then output a file, and I have Claude consume the file to actually do the real work. So Gemini has got the Context7, so use Context7 to search for the key differences between Streamlit components v1 and v2. And now Gemini understands that it should use this MCP server. So here, MCP server that connects to the Context7 website, and it provides the tool, the correct tool for doing the query. And allow once, and there you go, you've got the result from the tool that it's going to consume and summarize for us. And there you go, you've got the key differences, which is a good thing because you can use this, you can, copy this, for example, and then you exit and go back to Claude, and then you paste it directly to Claude. Okay, Faniel, but you know that looking on the web for the best practices for building Streamlit components sometimes doesn't work well, especially because right now Streamlit components v2, I'll be honest, it's not really documented. If you go on the web right now, you won't see a lot of tutorial about it. Let's go to, if I type components here, limitation of custom component, and then you've got the component v2 API, and I think that's really it. So there's way more documentation and projects on the web on v1. So v1 is going to take way more weight over writing custom components. And we don't want that. We want to build custom components using the V2, the modern version. Thankfully, the Streamlit dev team has built for us a set of agent skills. And in those agent skills, we have all of the best practices for building Streamlit components. GitHub, Streamlit. Let's go back to the GitHub organization, and there should be, if I type skills here, agent skills. There it is. And here are all of the agent skills for Streamlit development. And in there, you will find the main skill for developing with Streamlit, which has a skill that reroutes to building a Streamlit component. If I look here, if I say build, where do I say build a Streamlit component? Oh, there it is. Building or packaging a custom component. Used skills building Streamlit custom components v2 skill, and never use a v1 for new components. So let's copy paste this to our actual project. Let's go back to our Chart.js, Claude Code. Oh, we actually have the skills. What are those skills, by the way? I don't even remember. Let's remove all of the skills for now. Bye-bye. And let's copy paste the skills from developing with Streamlit. So let's copy paste those skills here. There you go. And now you've got a new developing with Streamlit skill and a lot of sub-skills that Claude Code can use. Go back to our command line. It's clear. That is clear. Cloud, no, wrong projects. I think at this point you know Chart.js, right? Yeah. Use a skill on building Streamlit components to explain how to build a component. Okay, that was the broadest thing ever, but this is just to show that it's now loading the agent skill developing with Streamlit. We can go read the skill, by the way, but in this skill, you remember I talked for 30 minutes about how to build a new Streamlit component. This is probably all documented inside the skill. And this is probably the most up-to-date information about custom components v2. It's all in there, and it's managed by the Streamlit core team. So you can trust this file. And there's everything we need. Actually, we don't need the others there. That's okay. But because this is agent skills, those skills are loaded little by little, only when it is needed. So I think if I remember, this is inside the context of the coding agent. And when the coding agent understands that it needs to load the Streamlit skills, it reads the full skill, and then it will understand, oh, I need to build a new custom component. I need to head to the building custom components v2 skill. Here's the skill, and there's other references to other best practices for custom components. If I go back to my coding agent, there you go. It has all of the v2. There you go, Streamlit components v2, set state value that we saw beforehand in the template, remember? Set trigger value, and a lot of information that you can read later on before going to sleep to understand how Streamlit components work. And now we are very happy. Yep. Okay, maybe it's actually time to try and work. So let's go to our coding agent. After 1 hour of talking about the backset, the backstage, let's see how I would do it in not maybe 5 prompts, okay? 5, 6 prompts, maybe not 2, 5, 6. Depending on how lazy you feel, let's say, there are usually multiple types of workflow. Some people like to work in a very spec-driven workflow using tools like SpecKit or Conductor or OpenSpec. Let me find them for you. If you go to OpenSpec, I will put them in the description below if I remember. But those are all packages that manage a spec-driven workflow for you. So they will build a workflow for specifying what kind of features you want to build and how you want to test that the feature is correctly implemented. They have a specific workflow like specify, plan, task, and implement. And then you need to follow it to the groove. And if you don't, well, you're not going to work. But I think this is, for a solopreneur like me, this is too constraining for me. I don't want to go through such a workflow. But I would not do the opposite. Like, I would not only do the build me a Streamlit component for Streamlit Chart.js, because even if it has all of its tools at disposal, because there's documentation, there's the agent skill for building this, and there's Context7, there are even reference projects around the folder. Because this is too broad to YOLO, I don't really trust the way it's going to work in the problem. It's like if you ask your junior intern to do it for you. Like, okay, build me the next Stripe. I mean, it's going to look at me like this, like, yeah, I consider a coding agent like a small intern, a junior intern that doesn't really know yet how to correctly structure those very broad projects. And this is how you need to mentor this little shark, The first thing I tell it is, well, instead of like going directly into code, maybe you should try to research and to brainstorm solutions and to talk about it with me. So I like to follow a research, plan, and implement workflow. So here we are talking about researching. In research, we are exploring the code bases, the documentation, reference, and we're trying to understand how the project is going to go, what kind of challenges we're going to face. We are not yet considering how to actually implement the code. The planning of the implementation will be at the second phase after the brainstorming. And then the third phase is just implement, YOLO, go for it. Let's do the research first. For the research, well, hopefully you understood that, I've been talking about the setup for an hour. We have, if you skipped on an hour because we're a little too lazy, let me explain again. We have a folder. Okay, let me open a new one. We have my Streamlit components folder that contains a lot of reference projects, and we want to use Streamlit Bokeh and Streamlit eChart as reference projects. And we are lucky because Streamlit Chart.js is also already a reference template project. So that's free reference project to use to understand how to build the project. Then we got skills. We got inside our cloud skills, we have a developing with Streamlit skills. Wait, not skills. Skills, and yeah, you've got a lot of Streamlit skills that the coding agent can load to work on the component. And then last but not least, you can also search on the internet on how to do it. So let's go back here. And I think I don't really have an order to do it, but let's start with best practices. Load your building Streamlit components video best practices. Wait, I am going to look for from your skill to understand conventions or something. Okay, let's go. Yeah, let's go on the back right here. I'm having fun with those animations. Hoop, 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 hoop. Yeah, you can tell. It can disappear, reappear. I can also. Oh, up. I don't know. Which one do you prefer? Tell me in the comments. Where should I go? Which corner should I go? Okay, so it's loading its skill and it's reading its. Why are you reading theme CSS variables? I don't know. I decided that. Oh, it is in. It is actually in custom components. I didn't actually know. There you go. Now he already has a bit of context about best practices for Streamlit component. Next, we are going to add our Streamlit bouquet for this session and also our Streamlit e-charts, because we want our coding agent to analyze both of those projects to build the Streamlit Chart.js. Read the Streamlit bouquet and Streamlit e charts projects to understand, no, to explain, maybe to explain the structure, how to bridge, I don't know, Python and JS in a Streamlit custom component. Okay, and so we added to as working directory, we added Streamlit bouquet and Streamlit e-chart. It should be able to find those. Now it is going to, yeah, it is going to analyze. This is going to take some time. By the way, notice that it uses, I think this is a sub agent. I need to check, but I think the explore is a sub agent. So here it's actually spawning a new sub agent to go and look for Streamlit bouquet and give back the results, and go to Streamlit e-chart, work on Streamlit e-chart and give back the results, so that its head is not stuffed with reading the whole code base. Okay, you whatever, do your stuff. Yeah, I think this is going to take some time. Yeah, maybe. Do I have chocolate? I don't think I have chocolate. Do I have Kit Kat? Because this is going to take some time. Okay, where is it? By the way, if any of you knows how to, I was in Japan in November and I got those strawberry Kit Kats, and I don't know where to find them now. Okay, no, this one is not in Japan. Actually, wait, this is not from Japan. This is, I got them here, but because I've got a peach one from Japan, and I don't know where to find the peach one, so I'd like to know what's the Amazon of Japanese goodies. Tell me in the comments. I'd really like to know. Oh, it's finished. I would probably need to read all of this. If you really wanted to learn, then you would ask questions about this conversation here. But right now I am in YOLO mode, so I am going to do it without reading. And finally, maybe you should research the Chart.js library. Oh, I should maybe specify the goal. Goal of this Streamlit Chart.js project is to build a Streamlit component v2 for Chart.js. So research the Chart.js library documentation on how to mount a Chart.js component from JSON. Yeah, I think this is good. And now I'm going to eat my Kit Kat. Okay, usually when I'm bored like this, I generally go to open a new shell on the side and go to Chart.js. No, not Chart.js, but Chart.js. I love it. Like cd Chart.js, it automatically brings me to Streamlit Chart.js. It uses Zogzide for this. Really good. Love it. Yeah. Whatever. So while it's working on researching, I like to spawn another agent on the side to do some other stuff. So we can start building some documentation. So I don't know if you know about material MK docs, but if we're using a Python project, we can use material for MK docs to immediately spawn a new documentation website. And coding agents are generally pretty good with material MK docs. So wait, let me go to Chart.js and uv pip install. Is it mkdocs material? I don't remember. Let's uv pip install material mkdocs in Python. I don't remember the name. I think we can close this one. Yes, so pip install is mkdocs material. I didn't remember. And there you go. And then we will create a new material mkdocs for this project. Add an index.md file and agent folder, let's say, to store the memories of previous agent runs. And there we go. On the side, it has finished thinking about Chart.js. I think it has already started on the left building its roadmap for building that Streamlit Chart.js. So now I want to summarize all of this research into an artifact that I'm going to put. Why do we need a new? I'm not sure we need a new. We don't need the new. Just build the docs folder and mkdocs YAML. I mean, you can do it by yourself. Anyway, here on the left, the research is done. I like to store everything, anything that an agent has worked on. I like to store it inside a file so that I can read it and so that a future agent can read it, or anyone can read on the memories of an agent. So here in the research, we are now going to ask to summarize all your findings into docs, and normally the docs folder should now exist. Right file, we have docs folder, and in docs there should be agents. So we have agents, and then hopefully if we do RESEARCH.md, it should put it inside our material MK docs. And I want to explain, let's say, integration patterns, challenges. I like challenges we expect to hit. I like challenges because it forces me to understand what are going to be the difficult parts or the complex parts where the agent is going to like produce actual AI slop. So challenges we expect to hit, and then maybe assumptions that need human validation. Like for example, we didn't talk about event selection, and hopefully it will ask me on my opinion on should we do event selection immediately or if we can defer it for later. And then I don't know, let's say explicit unknowns without answers. So now we begin to have an idea of the complexity of the project, and now our MK docs is ready to go. which means if I open a new tab here and use the UV run mkdocs serve with a live reload, it will open a new website, hopefully. And there you go, you've got Streamlit Chart.js. Welcome to the documentation for Streamlit Chart.js. And in agent memories, we will have a folder with all of the files generated by previous agent runs. Yeah, the way I usually work is I like to produce as much markdown as possible and render them using material mkdocs or Docusaurus or any markdown to website component. And when it's done, it is still reading files. I don't know why. Yeah, okay. Now, oh, by the way, to steer it, the docs is the root of a new mkdocs material project. So you have to add the page to mkdocs. Oh, do you want to create the? Yes, I want to create it to mkdocs.yaml. Do you want to make this edit? Yeah, I don't really care. Yep, there you go. And now, if I go back, so the research is not in agent memories, I think. We need to do something about it. And here, yeah, the markdown formatting is not really good, but you can see all, there you go, generated by the agent, research gathered from Chart.js official documentation, analysis of Streamlit bokeh and Streamlit eChart, and skill reference. And there you go, you've got the full research of how to build your new Streamlit Chart.js component. I should be reading all of this. And let's say assumption, let's look for assumption requiring human validation. Yeah, needs validation. Is it the desired API? There's a lot of stuff that we normally we'd like to talk about. But for now, let's go back to our code. And we clear the conversation. We stored the context anyway. Destroy this for now. And I think let's destroy this for now. Let's go back to Claude Code. And our Claude Code has a research. If I go back here to research, now in its docs, we have a research markdown with all of the information it needs. You are a Streamlit expert. Let's do a little prompt engineering. You are a Streamlit expert. Your goal is to plan the building of a new Streamlit v2 component to for Chart.js. Maybe before doing this, I do want to show one last thing. You know, I should have read this research markdown, but I was way too lazy. So what do we do when we are too lazy? We ask another agent to do it for us. So let's ask Codex in IMP to do it for us. Research was done in, and then point to the folder agent research. I think it's not research like this. Is agent, it's research. So research.md. Be brutally honest and suggest refinements or criticisms on every point from the research. Write back your findings in docs agent research criticism. There you go. And now you've got, like to have an agent on the side that criticizes the work of an agent. So they're all, they're all fighting. They're all fighting. Next, I can, and if I were really serious, I would then say here, read the suggestions and findings. Read the suggestions. Approve this for the research from an adversarial agent to refine your research markdown file. See, if I was really that serious for this component, I would actually ask it to read what the other agent says. So it's like, are we 3 prompts already? So we did 1 prompt for research, like maybe 3 for research, 1 for adversarial. So yeah, 4 prompts for research. Then we're going to go in plan mode. That will be 2 prompts, and then implement, that may be 2 prompts. Okay, 8 prompts, okay? Not 2, but 8. Understand that we generate a new document that we inject inside Claude Code. But let's kill this one, and then your goal is to plan a Streamlit v2 component. Start planning the full implementation. And now, normally it should go into plan mode automatically because it sees the word plan. But just to be on the safe side, you can press Shift and Tab to cycle between accept edits automatically. I should have done this for the documentation so that it writes the documentation without asking for my permission, and plan mode. And in plan mode, it is going to work on the different phases of the project. Maybe I can say by phases with a clear scope, testing, and done criteria per phase. There you go. And then in the end, we write down the plan in docs, agent plan. This is just for conservation. And now we are in plan mode. So it's going to act as a Streamlit expert, read the previous research, and plan the full implementation. And I think that's the moment where we wait, where we wait a lot. Yeah. While it is working, what should we talk about? I'm going to head to Streamlit.io because Streamlit.io has a gallery of existing components. And here you have Pig Walker, extras, iTables, interactive data tables, Folium for maps, WebRTC for real-time communications, we have eChart, AGGrid. You have a lot of pre-existing components that you can already clone and have your coding agent analyze. Like especially, for example, WebRTC, if you were the first one to rewrite a version with Streamlit version 2 using set trigger value and set state value, that would be very, very useful for the community. So those are small examples of things you could work on. Or just check, there's a lot of small components to connect to Google Sheets, Supabase, Folium, and sorted by trending. It was very recently updated. Now we can do search. ST chat from Ariash. Yeah, this is very fun, very fun. Don't hesitate. Chat box, true breaks. Yeah, building components. There it is. It's over. So now we have our multi-step phase. So I wonder, did it write the plan? I'm not sure it did. Not yet. Hopefully it will do it at the end. So normally I should read the full plan. Let's go and read it. The plan is written. First we do basic chart rendering, responsive sizing, JS code. I actually don't want to implement the JS code. Click events, yeah. We also, actually let's only do 1, 2, and let's only do 1 and 2 for now. We want the MVP. We just want to check that it works. And also because I don't know if I have enough quota to do this. So let's just do 1 and 2 for now. And we'll ship the rest later. So phase 1, Python side, we edit this. Pass config inside st.chart.js. And if you remember, this config should be passed to index.ts. So here we install Chart.js first, then we import the chart. We create a canvas, and on each render call, we destroy the canvas and create a new canvas. Then maybe, I don't know, yeah, why not? I think matplotlib works in the same way. That's okay for now. Set canvas from the heights. Yeah, that should go, that should do the trick. Testing manual, verify no console errors. Yeah, that looks good and responsive. Yeah, resize, because when I resize the app, I want to resize the chart accordingly. And also because this enables me to put the chart in tabs and expander, because the expander starts at height 0. So the component has a height of 0 in collapsed expander. But when the expander grows, I want the chart inside to also grow. I don't want it to stay at 0. So actually, let's also do the second one. Wait, let's type what to tell Claude what to change. Only implement option 1 and 2. Keep the others for another time. And yeah, there you go. And now I think we can auto accept edits. And now it went into implementation mode. So you can see it here, it's integration, and now we are in phase 1, basic chart rendering. And then we have phase 2, responsive sizing. And last but not least, we write the full plan in the documentation for further analysis. I would have preferred it the other way around, but anyway. This is the important part because, just as you don't want to your intern to build immediately without thinking about the game plan, it's way easier to edit the game plan than editing 10,000 lines of AI slop. I usually like to write the plan locally to edit it manually with VS Code instead of doing it all in command line, but that's okay. And maybe in the future we will have IDEs like Codex or Antigravity being more mainstream and stable. So this is the moment where I have to talk about anything else. We talked about components. If you missed it, there's a, I think there is a Streamlit. What do we call this? New Streamlit releases, I think. If we go to docs.io, quick reference, release notes. There's a new Streamlit version. I need to test it. We have dynamic containers where we run the app when tabs or expanders are opened or closed. This one I really want to try because that means we don't have any here, but we can bind widget state to query parameter. So you would see the state of widgets inside the URL, and then you can copy and paste the URL to send it to a friend of yours or partner or classmate, whatever. And when it opens the app with the query parameters will inject themselves in the widget, and they will have the exact same state of app than you from the URL. So that is very cool. Image link has a link parameter. ST page has visibility hidden so that you can, I would use this, I think, for example, for Stripe routing payments. You send to a hidden page to the callback something and then send back to the main page with your account ready to go. And yeah, some more stuff that I didn't try yet. Oh, it's asking for permission to do something. Yeah, I should put npm install in the list of permission. But let's put this on the side like this. Yeah, that's easier. Yeah, whatever. Yes, do it. Yeah, oh, it wrote the plan apparently. So if we go here and reload, oh, I didn't put, oh, I know, it's not alive anyway. So let's add in MK docs, research. Let's add a plan. We have a plan MD and UV run mkdocs serve live reload. Go back to our page and then read the plan. There you go. Here's the plan. Oh, is it done already? Oh, wait, it's done. Phase 1, phase 2. Now let's actually see the code then. So, what's nope, I want here. So we have a new example pi. Let's go full screen. Oops, sorry. So we got Streamlit Chart.js. In here we got the JSON specification of a bar chart with sales and a line chart, pie chart, or lots of charts. So that looks good. Since we've got Git, we can follow the diffs. It will be way easier. And Control B. We are loading chart from Chart.js. We are registering some stuff. Front-end state, nothing. We are not storing any information. Config and height will be provided by Python. So config the JSON specification and height for, let's go back here, and the height for the height of the component. Yeah, there's a lot of info, but yeah, you could have done this in 30 minutes, but now you can ask any other agent to read the research and plan MD, and it will immediately be able to work on the project without having you to re-explain everything every time. Fingers crossed, let's have a new UV run Streamlit run example, and this is where we cross fingers. Oops. Okay, does it work? Woohoo! That's what we're talking about. Poof! Yeah. There you go, and it works. There you go. How many prompts? 5, 6? Yeah, kind of 5, 6. And we have already good enough. Yeah, that's good enough. And then we've got the plan. And then maybe we can ask it, where's my agent? Let's go back to my agent. Write out the full implementation in docs agent implementation, which date 26 March 21. And now, oh yeah, I need to add it to, don't read this. Yeah, okay, read it if you want. The main takeaway of this project is have your agent document everything, because when everything is documented, you can read the documentation, your agent can read the documentation, your colleague can read the documentation, everyone can read every documentation generated by every documentation agent. Add it to mkdocs, we forgot. I should add it to the Cloud MD, but whatever. And now we can read the implementation plan. Here it is, phase 1 and 2 implemented. Key decisions, there's some key decisions that we can criticize. But yeah, now we can give this to any other agent to start working and get on it, you can ask Codex to analyze this implementation plan and say, this is wrong, this is right. You can ask Gemini to work on better looking dashboards or downloading JSON specification from the Chart.js website to put inside the examples. From there on, you can do anything. You know, sky's the limit. This is a good looking, but understand that you can generate a Streamlit component in 5 prompts. Understand that if you want to build it in 5 prompts, your agent harness should be like this. You should have your tools configured, your context, your runtime, your environments, are you sandboxed or not, what kind of website you can check or not check, hooks, skills, etc. Reference projects. And then afterwards, you decide on the workflow, spec kit, open code, or do it yourself, whatever. You persist all of the markdown, and then you generate a website from all of those markdown. And then you just go from there. So just pick any JavaScript library that you like and make it a Streamlit component, and then push the Streamlit component on the component's website, and then maybe you will get famous. And maybe when you are famous, it is something I want to share. So see, people are getting Streamlit creator badges from Snowflake to put on their resume. There you go, and I am getting one too, and you can too by building Streamlit components. So don't hesitate to drop your favorite Streamlit component in the comments below. I will see you around, and I send you this coding agent. Bye!